Okay, I hope everybody can hear me okay. This is a big room, and there aren't enough people in it to deaden the sound, so hopefully y'all will all be able to hear me. Welcome, thanks for coming. For those of you I haven't met, my name is Paul Robichaux, and what I'm going to be talking to you about today is how you can build mobile applications using Exchange Web Services on devices that Microsoft doesn't officially support or like or care about. As a practical matter, what that means I'm going to be talking about is developing mobile applications on Apple's iOS. Now, I'm going to talk in a minute about the reasons why I'm concentrating on iOS as opposed to Android or even Windows Phone. But what it boils down to is that I don't know anything about Android development, and Microsoft's already got their own APIs and their own tool sets and their own presenters talking about Windows Phone, so here we are. I like to start with a little bit of stage setting, and so to do that, I'm going to ask a couple of quick questions. How many of you have a smartphone on your person right now? Okay, that's about what I expected. I guess what I should have asked is how many of you don't? How many of you have acquired this smartphone or had you got your first smartphone within the last year? Okay, that's about typical. Most of the people who attend conferences like this have been smartphone users for quite a while. But in the broader market, that's not true. Right? And smartphones are exploding across every market segment, low-end, high-end, industrialized world, developing world. It doesn't matter. Everybody, everywhere seems to be buying these things. So that generates a lot of opportunity, but also a lot of risk. Because when you think about bringing smartphones into an enterprise network, all of a sudden, there are all these scary things that can happen. You can have a device that has really critical information on it that gets lost. Somebody leaves it in a public toilet. It falls out of their pocket in a taxi cab. They leave it on an airplane. They drop it in a restaurant. These things are small. They're relatively fragile. When you think about all the places that the data on them can be exposed, at a repair shop, at a wireless network, to the police, then you can see it's a little bit daunting. But having said that, one of the reasons that these devices are so popular and so common is because they can do so much. And one area where they can really make a big difference is in building mobile applications that do something specific to a line of business. Now, the details of exactly what an app like that does will vary according to what your business is. How many of you have the Channel 9 app on your phone? Okay, that's a perfect example. It may not look like it from your perspective, but that is a line of business application for the folks who organize and run conferences at Microsoft. It exposes some enterprise data, the schedule, the speakers, a Twitter feed, directly to end users. Okay, so when you look at that as a very simple example, you can get much more complicated examples. Imagine that you're Boeing. Boeing has a team of people who literally will fly around the world at a moment's notice to go fix a severely damaged airplane. The case I'm familiar with most recently was a case where a British Airways aircraft tried to take off with its engine cowlings unlatched. And so what happened, as you might expect, is as the plane picked up speed, the cowling ripped off, banged into the engine, caught it on fire, made a bunch of dents in the fuselage, and just generally made a mess along the way. So British Airways called Boeing and said, excuse me, I'm sorry to be a bother, but we can't fix this airplane ourselves quickly enough. Would you mind sending us some help? So here you have these hotshot field service people who need to be able to deploy in a heartbeat. Think about scheduling them, thinking about scheduling their travel, thinking about scheduling whether they have all the right tools and spare parts and supplies all ready to go at the same time. That's a great example of a line of business application that makes much more sense for mobile use than it would for desktop use. And there are many, many others across all kinds of verticals. So if we take it on faith, as I hope you will, that line of business apps on mobile devices are interesting and useful, then the question becomes, okay, well, which mobile platform should I care about the most? I'm not going to attempt to answer that, but what I can tell you is that there are some significant differences between platforms that come into play when you're thinking about how you'll develop with Exchange Web Services. Probably the biggest is that if you use Windows Phone, it's already got a set of native APIs that you can use to do this stuff. So I'm not going to talk about them. If you want to know how to do this and you're a Windows Phone programmer, you already know more about it than I do. If you want to do this on Windows Phone and you don't know how, there are other Microsoft sessions that will go into depth. So that leaves us with Android and iOS. Are there any BlackBerry users in here? Okay. That's fewer than there were last year, and that's probably more than there will be next year. I didn't discuss it as a platform because from a development standpoint, it's very similar to Android in that Java is a primary development language. Microsoft makes a Java API for Exchange Web Services available. but it is not, it has not been frequently updated, and I don't think much of it as a set of APIs. So everything that I say in the rest of this session is going to be focused on building EWS applications using pure XML. So your application in this model will construct a bunch of XML and push it to the server and get back an XML encoded or XML formatted response that you then will have to parse to figure out what the Exchange server said back to you. The advantage of that is that it works on every platform. It works on Linux, it works on Mac OS, it works on Windows, it works on Windows 8, it works on Windows Phone, it works on devices we haven't even thought about discussing. But it's a little bit more hassle because you don't get as much abstraction from the API layer itself. So I guess one thing I should say pursuant to that, if you're interested, and you have not yet been by Xamarin's booth on the floor, they have a solution that lets you write .NET Framework and C# code and have it run on both iOS and Android devices. So if you're not familiar with them, I talked with them yesterday. Their opinion is that you ought to be able to take Microsoft's managed EWS API, which currently is Windows and Windows Phone only, and run it using their tool set to build iOS or Android apps. I haven't tried it, they haven't tried it, it might work, it might not. But if you're at all interested in it, I would encourage you to drop by there and talk to them to tell them that you're interested in it so they can try it and find out if it works and let the rest of us know. So Exchange is a development platform. I used to have this really cool slide that showed the 500 APIs that Exchange has supported at different points in its life. There have been all these APIs going back to really about Exchange 2000. If you've ever developed or even heard of WebDAV, for example, that for a while, that was the one API that everybody was going to use forever and ever, and it was going to replace MAPI. Anybody remember hearing that? Yeah, well, guess what? Then we were going to have Exchange Web Services, which was going to be the one API, and I'm skipping over CDO, I'm skipping over CDO EXM. Those of you who've been around Exchange for a while know the story well enough to know that there are many other APIs that have been introduced with great fanfare and then faded. EWS is interesting because it's sticking. It's got some traction in the marketplace, both within Microsoft's own stable of products, but also more broadly. And in part, that's because Microsoft has done a really good job of peeling two different operations apart. One is, how do you sync data to the device? That's Exchange Active Sync. Exchange Active Sync has won that battle. Okay? It is so broadly supported on so many different platforms, even their major competitors use and support it. Okay? Game over. Will there ever be another sync API that takes its place? Sure, who can say? But at least for right now, if you're building mobile device applications that involve synchronizing data to Exchange, Exchange Active Sync is the way to go. However, and you probably knew this was coming, that's not really helpful for what we're talking about here. If you want to be able to build applications that talk to existing data, not synchronize a copy of the data to the device, but work on data that's on the server and leave it on the server, then it turns out Exchange Web Services is the way to go. And one of the cool things about EWS is that over time, Microsoft has steadily evolved it. So when EWS first shipped, we could see, or we call it CRUD. You could create, read, update, and delete mail items and folders. So the mail items could be calendar entries, contacts, mail messages. That was about it. Then over time, EWS has grown and expanded. So now you can use EWS to manage inbox rules. You can use it to download high-resolution photos of users from the Exchange Photo Store. You can set out-of-office messages. You can get free busy. There's all sorts of stuff that you can do, both in terms of manipulating the data in someone's mailbox or in a group of mailboxes, but also for provisioning and setup. So you really have a great deal of flexibility in the kinds of applications that you can write with EWS, whether you write them for mobile or desktop or both. So I do have a point, and I am getting to it, I promise. What I want to talk about in this session is how to use these Exchange technologies to build apps for iOS. So I'm going to talk about using Exchange Active Sync, primarily auto-discover. I'm going to talk about using EWS. And along the way, I'm going to point out a few areas where Apple's native development tools either make things easier or harder than they otherwise might be. And then I want to talk some about sort of the practical nature of using iOS with these services. Just like every other operating system, iOS has some things that it does very well. It does some other things that it doesn't do anywhere near as well. And some of those are relevant to building these kinds of applications and to using EWS. Okay, I'm not going to try to talk about Android development, both because I don't know anything about it and I'm not a fan of Google in the least. I'm sorry if there are any Google diehards or Google employees in here, but I'm sorry. Having lived 3 or 4 miles from Google's world headquarters, I just don't have a great feel for them right now. Windows Phone, there are already many other sessions that can teach you in much more detail what you need to know to build these kinds of apps on Windows Phone. BlackBerry, Jola, there are all kinds of other platforms where you could use these technologies because they're just XML, but that I'm not going to attempt to talk about. This also is not a complete guide to iOS development. How many of you in here have built an iOS app before? Okay, cool. In that case, you're probably going to find that this will be useful. If you haven't, I'm not encouraging you to run off and leave, but I will say that some of this may seem a little odd to you because iOS development is weird compared to traditional desktop development. It uses a weird language. Apple's tools look funny. If you're used to Visual Studio, you're going to look at Xcode and go, what the hell is that all about? Okay, but just like traveling to a foreign country, you'll adapt it to it pretty soon. I mentioned earlier that Microsoft has a managed Exchange Web Services API, and it's really quite good. It makes it very easy for you to build complicated EWS applications without having to deal with complicated EWS operations. But the problem is, at least right now, it requires you to use managed code, which means either sticking with a platform that natively supports it, or talking to the Xamarin guys. And I would have edited this slide had I known before last night that Xamarin was actually going to be here. So what does a basic pattern for developing apps using these technologies look like? There are a bunch of different ways that you can do it, but the simplest way to get something built and operating quickly is to pre-create the block of XML that you're going to send to the server. Now, in a few minutes, I'm going to talk about how do you know what goes in that block. But the simplest way to do this is to build it statically as a string or as a dictionary object that you store in your iOS application, and then stub in the parameters that you want at runtime. And you'll see some examples of what that looks like in a few minutes. The contents of what goes in these blocks is defined in the EWS and Exchange ActiveSync schemas that are on TechNet. As a practical matter, probably the best way to make sure that your application emits exactly what you want is to use a tool such as Fiddler to monitor what happens when you sync a Windows Mail or a Windows Phone 8 device to the server. Because there you can see the actual traffic, you can see all the parameters that Microsoft internally is using, and you may find that that's an easier way to do it than trying to copy the text out of the Exchange 2007 Web Services book or out of MSDN. Then once you've done that, once you have a block of data that you think encapsulates what you want the server to do, you're going to pass it to the server using an HTTP or HTTPS post operation. There are a few cases where you will do a GET, but 90% of the time, if not more, when you're doing something with EWS, you're going to post to the server and you're going to get back an XML encoded response. Now, the way I chose to do this in the demos that I'm going to do today and in the applications that I write is I use the ASI HTTP connection helper class. It's not the most modern. For example, I had to convert it to work around Apple's changes for automatic reference accounting. But it's pretty robust, it's well supported, it's well understood, it's well documented. So all things considered, it's probably a pretty decent choice. You may have your own library that your enterprise has developed. You may prefer somebody else's library. You may even want to write stuff using the CF Network raw socket classes. If you want to do that, more power to you. Then once you've posted some data, you're going to get back a response, which hopefully your network layer will aggregate so that you get a callback when all that data in the form of the complete response is ready for you. You're going to have to parse it somehow. iOS doesn't include a native XML parser. Now, you can argue about why Apple didn't do that. You can argue about whether or not it was a good idea. But the fact of the matter is that if you're getting XML data back, you're going to have to do something to parse it. What I chose to do, despite my distaste for Google, is use GData XML node. The reason for that is that there are probably 7 or 8 different XML parsing libraries that you could feasibly use on iOS. And they've all got advantages and disadvantages. GData XML node has got probably the best balance between the amount of memory it consumes at runtime, the amount of or the speed at which it parses XML, and the gyrations you have to go through to actually get it to parse something. So when you look at the sample code, you'll get a better feel for what I'm talking about. But in general, ASI HTTP connection and GData XML node are a pretty good combination for this class of application. So how do we actually make this happen? Well, one thing I didn't talk about before is how are we going to find the server we want to talk to in the first place? If you're familiar with Exchange, as I assume most of you are, then you know that AutoDiscover is a mechanism that Exchange ActiveSync provides for us to give the server some credentials and have the server come back with a manifest of services that we can potentially talk to. The contents of the manifest are actually not really important for our purposes because we're always going to be talking to the EWS endpoint. But there are a whole bunch of other services that if you wanted to, you could consume based on what's in the AutoDiscover manifest. For example, there's a service that Exchange uses if you have unified messaging deployed that you can use to tell the Exchange server to place a phone call for you. There are APIs that you can use to find out whether somebody has calendar availability at a particular time period. Okay, we're not going to be using those in the demos, but the first step to being able to use any of these services anywhere is going to be doing an AutoDiscover to get back the manifest. Then after we do that, we're going to use this method of blocking out some XML, posting it, and then reading the results to talk to these services that AutoDiscover has exposed for us. Notice what I'm not talking about here is all the plumbing and all the GUI stuff that makes your application look and behave the way that it does. Okay? You're going to do that in whatever way makes the most sense for your app, depending on the form factor, depending on the intended audience, depending on the types of devices you support. So I'm going to make a few comments about that as we walk through the sample, but that's not something that I can teach you about in the amount of time that we have here. One thing I can teach you about, though, is AutoDiscover. So let's talk about that a bit. So the whole idea behind Exchange ActiveSync is that Microsoft came up with a protocol, and they said, okay, we're going to build a protocol specification that talks about how things work, and we're going to implement the server side of that protocol, and then we will make the protocol spec available, and if you want to, you can license it so that you can use that protocol to talk to our servers. Okay, so it's important to keep in mind that many of the difficulties you hear about with various kinds of devices, how many of you know about the transaction log bug that happened a few months ago with iOS 6 and 6.1 devices? Okay, it turns out that's not a problem in the protocol, it's a problem with the way a particular version of one particular client implements a protocol. So the interesting thing for us to talk about is not the protocol specification as a whole, it's some specific pieces of the protocol that we care about implementing in our apps. Okay, the protocol is fully documented. Generally, Exchange ActiveSync is going to be interesting if you're doing something like developing your own messaging client. Let's say you wanted to develop your own calendar application for some reason. Well, you could do that. You could do that with Exchange ActiveSync, let it pull down, or use EAS to pull down your calendar data to a local database on the device, give people offline access, etc. Okay, as a practical matter, the people that are developing third-party calendars and third-party email clients are either, for iOS anyway, are either depending on the system to actually perform the synchronization and then just using the system data store, or they're not talking to Exchange at all. Okay, they're using IMAP and POP so that they're not getting any of the benefits of using EAS, which is really too bad. The exception to this is that everybody who wants to talk to Exchange in any form will benefit from using AutoDiscover. And since we want to do that, we need to talk a little bit about how AutoDiscover works and how we can leverage it. The idea behind it is that we ought to be able to ask the user very simply for their email address and their password, and then use that to figure out what server to talk to. And then once we figure out what server to talk to, ask that server to give us back the manifest that I mentioned before. The way that AutoDiscover does this is different depending on whether the client is joined to a Windows domain or not. iOS devices are not ever going to be domain joined, so we're pretty much just going to ignore that part of the AutoDiscover process. The good news is that simplifies the code we have to write, and there is no bad news, basically. How often does that happen, right? I need to get better jokes. I say that every year, and yet my jokes never get any better. Okay, so the first thing we need to do to successfully use AutoDiscover is we have to have some way to get the user's credentials. This can be through a login form. On iOS devices, we can use the system keychain to retrieve them if they've already been stored. But one of the things you need to know about the keychain, and one of the frustrations in building an Exchange-enabled app on iOS, if the user has already got an Exchange account defined, you can't get its credentials. And that's on purpose. Apple doesn't want anybody to be able to write an app that plunders somebody's corporate email credentials. How many of you saw the post by Adam or Paul about LinkedIn and EWS this week? Okay, if you didn't see it, let me digress briefly because this is brilliant. So where are my LinkedIn users at? I use it, I'm not afraid to admit it. So you know that in LinkedIn, it's got the little bar across the top that lets you put in your credentials for various email services, and it will pull down your contacts. Well, they just added the ability to do that with your corporate or enterprise Exchange account. There's a little box that says Outlook, and if you click that icon and type in your credentials, then it will do an auto-discover. It will find your Exchange server, it will log in as you, and it will pull down not only all of your contacts, but it will also apparently mine your sent items folder looking for more contacts. So this is a classic good news, bad news kind of scenario. If you're an end user, hey, this is awesome. All I have to do is type in my credentials and it will find all the people I know and add them as LinkedIn contacts. How cool is that? On the other hand, if you're a corporate IT or you're an Exchange administrator, you're probably not really enthusiastic about having LinkedIn plundering your email data. So it turns out one of the cool things that we have the ability to do in Exchange is to block individual EWS applications. So you can use set OA virtual directory and set CAS mailbox to block specific applications by user agent. So you can turn off LinkedIn's ability to reach into your Exchange store and get people's contacts if you want to do that. I think it's cool because it's a great example of EWS being used for interesting things. Now, as a user and as an admin and as a security guy, I hate it because I don't like the idea of my users ignorantly typing in their credentials and having them be captured or stolen or compromised in some way. I love LinkedIn, but they don't have the greatest track record with security competence at this point. So collect the user credentials. That's easy. And then there's a well-known set of endpoints that you query for AutoDiscover. If you read the AutoDiscover spec, it tells you flat out, hey, if you are publishing AutoDiscover information, here's what clients should be asking for, A, B, C, D. If you're a client, here's what you should be asking for, A, B, C, D. So if you read the spec, it becomes very obvious what you need to do to actually implement this. At each one of these steps, at each point that we query something, we're going to get back a very small number of possible responses. One is that we'll get back a manifest. Great, in that case, we can stop and parse the manifest and know where the service endpoints are. Another is that we may get back an HTTP redirection. How many of you went to Greg Taylor's Client Access Server session yesterday? Okay, if you didn't go, one thing that you may not know is that in Exchange 2013, Exchange 2013 does not issue what are called HTTP 451 redirects anymore. And the reason for that is that handling a 451 redirect properly is kind of tricky on the client side, and most clients didn't do it right. So the AutoDiscover spec says that the server is allowed to either send you an HTTP 302 or an HTTP 451. Now, in 2013, and I presume future versions, we're only ever going to see 302 redirects. So if we get a valid response, we're good. If we get a redirect, then it's the client's responsibility to follow that redirect to wherever it points, or we might actually get back an error. Now, the errors can possibly include 401, which is the HTTP error code indicating that you need to authenticate to the server. One important thing that I want to point out to you, and you're going to notice this when we look at the code in just a minute, all of this stuff, every bit of it, is pure HTTP. Okay? There's no special protocol. There's no special authentication. So your code will authenticate to this server the same way it would authenticate to sign in to Netflix or to sign into an IIS-served intranet site. It's pure, basic HTTP authentication over SSL. So the first thing we're going to do, or the first thing the AutoDiscover spec tells us to do, is to try an HTTPS post operation to domain.com/autodiscover/autodiscover.xml. So for the rest of this slide, whenever I say domain.com, what I really mean is whatever domain it is you're trying to connect to. So you do a post, and if you get back an answer, great. That answer may include a redirect telling you to go someplace else, which is perfectly all right. I get it, it works, but it's just on a tape delay. Next, we'll try autodiscover.domain.com. And if those fail, then we'll try an unauthenticated HTTP GET. Now, the point of doing the GET here is to say, okay, maybe the problem is that there's a firewall, there's a namespace problem, there's some reason why we can't do either an HTTPS connection or a post. So we're going to try just a GET, and if things are set up correctly, that ought to lead us to a redirect that will get us to the manifest that we want. Our last chance, in this case, is to look up the DNS serve record that may be registered for autodiscover in that particular domain. Very few companies actually publish this because if you've got autodiscover set up properly, and if you have the URL set properly on your Exchange server, then these first 3 steps will deliver the answer. Now my keyboard's on a tape delay too. So the server can come back with a 302, in which case your client has to follow it. It can come back with a 403, 404. It's possible that it will come back with some other error like invalid response. I got that a lot when I was first building the code that you're going to be seeing in a little while. It can also come back with the manifest itself or with an autodiscover response indicating that you've violated some constraint. Okay, for example, the autodiscover schema says that there are particular elements that are required in every autodiscover request. If you don't include them, then you'll get back 600 invalid requests as an error code. So you need to be able to, in your code that handles these responses, look at the response you get back, determine whether it has the response elements in it that you want, and then either retry or prompt the user to make some sort of change depending on the results that you get back. Okay, I mentioned the 451 redirects. Those are dead and gone, thank goodness. The Exchange 2007 Exchange Web Services book is pretty good, and you can get it inexpensively on Amazon. As far as I know, there is not a 2010 or 2013 version of the book, which is too bad, really. And then this long URL, which will be available in the slides, has got a really comprehensive guide to everything you need to know about using autodiscover if you're writing applications using Exchange ActiveSync. So with that said, let's see how you actually do it from iOS. So this is an actual piece of code from the application that we're going to be looking at in just a minute. For those of you that are not familiar with Objective-C, let me see a show of hands. How many of you are not Objective-C programmers or have not seen it before? Okay, cool. So this looks a little weird, but it's okay. We can get through it. So some of it's normal, right? Curly braces, if, assignment statements, that's all good. Where things start to break down a little bit is when you see these funky square brackets. This is just a method call. So in this case, I have an object called AutoD, and I'm calling its connect to server method. Okay. Here, I'm getting the server URL property and assigning its value to the server URL property of myself. And you'll see what that means in the context of the object in just a minute. Then here, I have an object member called oof, which is actually a class instance of the out-of-office class. So I'm saying self.oof, get current oof state. Now, Apple uses very different terminology. They call these things messages. So instead of making a method call, they would say that I'm passing the get current oof state message to the oof member property of the self object. Okay, the point is, whatever you call it, it's the same basic idea. I'm telling the code to take some action here, even though the syntax looks very odd if you're a traditional C or C++ or C# programmer. However, it turns out it's actually a little more challenging than this to write the code that actually runs when you call connect to server. So let's talk about that. First, I think a demo is in order. I discovered this morning that the show network really hates my demo code for some reason. It works great when I have it tethered to my phone. It doesn't work at all when I have it running on the show network. So we just won't do that. What you're seeing, for those of you that aren't familiar with it, this is Apple's development environment. They call it Xcode. And it has some superficial similarities to Visual Studio. There are some parts of it that look very familiar. Right? It has a code editor. It has syntax color coding. Oh, darn it, my connection just dropped. Okay, that's more like it. Okay, so in this application right now, I have send automatic replies turned on. I have a message that says this is a test message. And if I hit the refresh button, okay, then it appears that those changes have posted back. And the way that I can check, actually, there are a couple ways. One way is that I can look at the settings for this account and see whether OOF appears to be turned on or not. Okay, notice that the message text I included here shows up, and if I save it here, and refresh the contents, in just a minute it'll appear. Now, if you want, I can send a message to this account and we can verify that Exchange actually sends an out-of-office response, but I hope you all trust the Exchange team enough so that we don't actually have to do that. So what this application does is it lets me go through and set the properties of the user's out-of-office message in the same way that I would if I went into OA or if I went into Outlook. The difference is I can do it from my mobile device, and this is all done by constructing XML and blasting it up to the Exchange server. So with that said, let's take a look at some of the actual code that does this to give you a feel for what's involved. So in the AutoDiscover class that we're going to be using, and I switched a little bit prematurely, it turns out that using the code template that the TechEd folks gave me to look at code on screen is really an eye chart experience for people in rooms like this. So we're going to look at it here instead. Okay, so you remember a minute ago I showed you that method call to connect to server. Well, this is part of what the connect to server method actually looks like. And there, again, if you're not used to Objective-C syntax, some of this may seem a little off-putting, but you should be able to follow along and get the basic idea. So there are two ways to send data to Exchange ActiveSync and Exchange Web Services Server. You can use what's called POX, which is plain old XML, or you can use another standard called SOAP, for Simple Object Access Protocol. Exchange 2007 only supports POX. Okay, how many of you are thinking about or interested in writing apps that will run against 2007 and 2010 and 2013? Anybody? Okay, a couple of you. In that case, what you're probably going to want to do is use AutoDiscover to figure out what kind of server you're talking to and then decide whether you're going to send POX or SOAP. Everybody else, if you don't care about talking to 2007, don't send POX, just use SOAP. And you can see this is not well formatted, unfortunately, but you get the sense that here there's an AutoDiscover XML element. It contains an email address element, and it specifies what schema we want back. This does the same thing, but it specifies a bunch of other things. We want the external EWS URL. We're going to get some user settings back. So the actual response that we're going to be sending is this string here, and we sub in the username. So then to actually make the connection, we create a new ASI HTTP request object and set a bunch of properties on it. We get the username and password. We indicate that this has got to be text XML as a content type. The Exchange server will not talk to you if you don't include that. We set a timeout. We tell the library that we want it to use standard IETF approved redirect behavior. And then we add the post data we want, which in this case is our block of XML data. Now, up here you'll notice I used POX on purpose because I wanted this demo to work against Exchange 2007 and later. So I'm guilty of not taking my own advice there. Then to actually execute the request, because we're able to use ASI HTTP connection, all I have to do is tell the request object, hey, start yourself synchronously. And it will go and run until it comes back with a result. In a real application, if you were doing this as part of a more complicated tool, you'd probably use an asynchronous request. But the same basic idea occurs. So I make the request, look at the status codes, and if we didn't get an error, then that means we got a bunch of data back. And this is a really fancy, convoluted way of taking that data block and putting it into an object that we can then parse into an XML document using GData XML document. And then we can pick out the parts we care about. Well, it turns out the parts that we care about are the auto-discover SMTP address response. So we're going to pick through that, and then what we're going to actually get back as a child of that are protocol elements. Okay? We can have web, we can have exchange, we can have EXPR. In our case, the only thing we really care about, if you look at the returned auto-discover manifest, you'll see there's all this other juicy stuff in it that we're not interested in. The only thing we want is the Exchange Web Services URL. So we parse through, we're looking for the URL that's tagged for that particular service, and then once we find it, we preserve it by setting it as a property of the auto-discover object, which in this case is referred to by self. Then we get done, we return yes, and our program goes about its merry way. So you can see, even if you're not an Objective-C programmer, and even admitting that this has minimal error checking and is not written as robustly as you would if you were going to make a multi-million selling App Store app out of it, you can see this is really pretty straightforward. And you could abstract some of this away if you wanted to refactor the code a little bit. I chose to leave it this way so you can see exactly what the order of operations are and how they work. But you can see this is no more than 20 or 30 lines of code, so it's not super complicated by any stretch. Now, what about actually getting the out-of-office state? Well, this is pretty interesting because this is not a whole heck of a lot of code either. As a matter of fact, it's enough that I could easily fit it on one screen. So if you look at this code, you're going to see some commonalities to what we just did a minute ago to get the auto-discover data. We make an HTTP request that's going to a particular URL. We set the username and password on the request so that it will properly be authenticated when we make the request. We add this text XML header, and then we append this block of XML data for our post, this request. Then we, on the OOF request object, call start synchronous. So what comes back, actually, let me find you guys the actual request object so that you can see it. Okay, so when you actually open the object itself, and this is poorly wrapped, unfortunately, but I can unwrap it a bit. You can see this is a SOAP envelope object that has a bunch of parameters and a body, and in that body there's a single set user OOF settings request, which contains a mailbox entry, which contains an address entry, and it contains a bunch of settings for the actual OOF. So in this case, everywhere you see a %@ sign, that's an external parameter that gets substituted in at runtime. So if you look at what we're doing here, and that's probably far enough for you to be able to get a sense. To be able to post this request, we need to know the address of the mailbox we're talking to, and then we need to set a state. We need to set whether or not this is for external or internal audiences. We need a start time and an end time. and then we need an internal reply and an external reply. Okay, so when we send the request up to the server, this is actually what's getting posted to the server. But it follows the same pattern we talked about before. I have a block of XML, I plug in the parameters I want, I HTTP or HTTPS post it to the server, and then I get back some data that tells me whether what I wanted to do was successful or not. Okay, so this is just showing you the guts of what that request block that gets pushed to the server to set the out-of-office state looks like. So when we're getting settings, I kind of jumped ahead of myself a little bit here. When we're getting the settings, it turns out what we get back actually looks like what you just saw. So we're going to get back a complete XML document that begins with an indicator that it's XML, includes a namespace, talks about this, it describes the schema. So all we have to do is take that data and parse it by picking it apart. So if we switch over and look at the get current OOF state routine here, let me just get that queued up and then we'll switch back. Okay, so here's our block of XML. You've already seen what happens here when we actually post the request. And now we get an answer back. We want to take the XML data and we're going to break it down so that we get the namespaces that we want. So the way you have to do this with GData XML is you have to create an object called an NS dictionary. A dictionary is just a set of pairs of data where you have a key that you use to look things up in a dictionary, and then you have some value that's associated with it. If you think of looking up words in a dictionary, then the word is the key and the definition is the value or the data. So long story short, you have to do this because of some tedious baloney that is implemented in Google's library. But having done that, now that I've got that data, I can say, okay, the thing I care about is a response message element. So in this case, if I have an error, or if I didn't find a response element, or if I found 0 response elements, and you have to have this checked because there's some edge conditions in Google's library that make it handle the parsing poorly, then I'm going to come back and say, oops, wait a minute, no, this didn't work. And you can say I have a to-do comment reminding me, hey, put up a warning dialog or do something to tell the user. But if I get a response, then it's going to be in the OOF settings element, which is a child of get user OOF settings response, which is a child of the body element. So when I call nodes for XPath, how many of you are familiar with the term XPath and have heard that before? Okay, if you haven't, XPath is very much like OPath or even, God help us, like LDAP filters in older versions of Exchange. It's just a spec for you to specify a path to some object in an XML document that you want to pick out. So if you look at what this is doing here, the XPath says in the namespace named S, there's an element named body. It has a child in namespace M called get user OOF settings response, which is a child in namespace T of OOF settings. Remember a minute ago when I said you had to do all that dictionary namespace stuff? This is why. Because otherwise you have to include every namespace element and it makes your nodes for XPath statement about that big. So what I'm telling the parser here is, okay, take the XML data that I got, and I want you to walk through it, and I want you to find just the child elements that I'm interested in. So we check and see whether we get anything back. And if we do, then we parse the individual elements. We parse allow external OOF, and if we find it, we take it apart to figure out whether or not it's allowed. It's either going to be enabled or disabled. We do the same thing for the text of the external reply. So it's not really interesting to look at this code because it's just doing the same thing for each of the elements. Look at the element. If that element is present, get its value, and then store the value somewhere that we can use it in this object. So we do the same thing for the duration, external audience, the OOF state itself, and then we're done. Okay? Because remember, what this method is doing, this get current OOF state method, is it's getting all the state data that the server has returned for the out-of-office state. Now that we have that, we can update the controls in the user interface, we can ring a bell, we can do whatever we want to with it now that we've retrieved it from the Exchange server. So setting the state, I already showed you what the XML data that gets returned when you push the state back up. This is the opposite of getting it. Okay, we have some controls in the user interface that let us affect what the schedule for the OOF is, or what the text of the message is, or whether internal and external users, either both or neither, get these messages. So to set the state, we need to get those values out of our controls and format them in the way that Exchange expects to see them using the EWS schema, and then HTTP post them back to the server. I'm not going to show you that code for the simple reason that that operation is exactly the same as doing an HTTP post for auto-discover or an HTTP post to create calendar items, which is what I'm going to show you here in just a minute. One of the most powerful things that you can do from a line of business application, and people have been slow to realize this, but they're starting to catch on, is exploit all the data in your calendar. Okay, the reason for that is really simple. Your calendar has got all sorts of useful information because your calendar knows when you have meetings, it knows when you're free. When you do have meetings, it knows who you're meeting with and for how long and for how often. So when you think about a traditional line of or a typical line of business application, when what you want to do is find out whether you can do something or find out whether something is available and then reserve it or book it or schedule it in some way, then having this wealth of calendar data is really useful. For example, there's a large utility company in Florida that uses a line of business app very similar to the ones I've been talking about to schedule field service. Truck runs is what they call them. So when somebody has a problem with their electrical service, it actually is a problem that the utility is in charge of. Everybody's got a handheld device, and everybody can schedule field technicians. They don't have to know which technician is available, but they have an app that will let them find when a technician will be available and schedule it like that. Okay? That means that everybody in the company essentially has the ability to dispatch a repair unit or dispatch a truck to any customer anytime who's having any kind of problem, which is really pretty powerful. Okay, a lot of other similar things that you can do all around calendaring, as long as your calendar has got meaningful data in it, which pretty much everybody's does. So I want to show you a quick demo of a slightly different application that leverages some of the calendar stuff that you have the ability to do with EWS. Because one thing we haven't talked about so far in our discussion of regular Exchange, one thing we haven't talked about so far is how do you read individual data items? How do you create individual data items? Well, it turns out that it's essentially the same process. It's all HTTP posts. That little Wi-Fi thing is hypnotic. I'm going to have to be careful not to get hypnotized into looking at it. I see it's going to be like that. Okay, there we go. So let's take a look at what the app does. Okay, so all this does is show us what's in our calendar. Actually, this is my appointment for tomorrow. It begins at 4:30 a.m. and it continues to 10 p.m. I figure that's the only way I'm going to get one. How many of you have braved the line and gotten your services? How many of you have been and looked at the line and said, oh, maybe I'll do it tomorrow? Yeah. Well, pretty soon we're going to run out of tomorrow, so I'll see you all there at 4:30 tomorrow morning. I'll bring coffee. That's a joke, by the way. I won't get there a minute before 6. But if you take a look at what's happening here, in the actual mailbox that's associated with this guy, then you'll see that all these calendar appointments that we just see in the app are coming straight out of the Exchange calendar. So this is a really simplistic representation here. It's not much to look at. It could have a lot more graphical flair and flash to it, but the point is that this code enables us to get stuff. Oh yeah, thank you for telling me that out of office is turned on. I appreciate that. I guess since my demo is done, I can turn it off. So let's take a look at what makes this code go, because there's some differences in the way that we talk to EWS here that are interesting. The first is that the canonical way that you get data in EWS applications is to make a call to a routine called find item. So find item requires you to create what's called a shape. You can think of this like a template or like a query. The shape determines both what objects you find and what properties on those objects you actually get back. So the shape for our particular query here is to find calendar items in the well-known calendar folder, but not subfolders, beginning yesterday going through the end of the week with a maximum return value of 500. And there are a few specific parameters that we ask for in the shape code. So we will get some kind of result back from find item. It'll be an error if we've asked for something that doesn't fit the shape. Okay? I've tried really hard to come up with a good analogy for what it means to violate the terms of a shape, and I haven't come up with a good one yet. But the basic idea is that the schema defines what you can and cannot include in a shape, and so if you ask for something inappropriate, like the start time of an email message, then you'll get back an error from find item. It'll say, wait a minute, I don't know how to include that parameter because there is no such thing. You can't have a duration on a contact, for example. Although, I don't know about y'all, I know some people it would be good if I could, right? So find item is going to return something to us, either an error or an XML structure that we then need to iterate over to find out how many items we've got. Because we don't have a precise count and we're not going to get one. We only know that we'll have between 0 and 500 items that we have to go over. So the find item request itself is just a block of XML. Find item, we don't want it to traverse the entire tree, we just want it to traverse this one folder. The item shape is an ID-only shape, and it's got 3 properties. We want the start time, the end time, and the item subject. So this is the template for the things that we're looking for and what data we want returned. Then for the calendar, we want 500 entries, starting on the 3rd at midnight Pacific time, and going until the 7th at midnight Pacific time, and only in the distinguished folder known as calendar. If I change this to inbox, for example, I wouldn't get any items back because I would be asking for calendar items in the shape in the inbox folder, but it would be a legal query. Okay? But if I wanted to actually get back a different type of item out of that folder, then I would have to do something different. So this is just a block of XML that we're going to send up to the server using the same HTTPS post mechanism we've been talking about. And we're going to get back a block of XML using the same mechanism we've been discussing that will have the data we want in it, if any exists. So to look at the items that come back, let's flip back over to Xcode. And let's take a look at ViewDidLoad. So here, what ViewDidLoad is going to do, when the view gets loaded, then we're going to call this routine called getInitialItems. Now you can see what's happening here. We have this big blob of XML. You can pick out a few terms like base shape and parent folder IDs. It should look very familiar to you from the XML that you just saw. So we'll assemble this as a block and make it post data and start a synchronous request. And then when we get back some data, we're going to pick through it, but we're going to do something a little bit differently here. So we get back a response message, and one of the things we get back in this find item response message will be an array of objects. Now, they're not represented in XML as an array. They're represented as children of that same element. But the XML parser we're using has the ability to take that data and turn it into an array. So that's what we're going to do. We're going to say, hey, would you parse this? And then once you've done that, we're going to get back an array called cal items that will have a count. So now we know whether we got any items back. If the count is greater than 0, then go through each of those items and add it using insert row at index paths, which is what gives us. Oh, great, now I have to reconnect. That's the code that gives us a list of items on the right-hand side, or sorry, the left-hand side of the window, I should say. So we just add each one of those, and then there's some other code in the other views that gives us the details, such as they are, for any item that we touch out of that left-hand list. So you can see, once you understand how to use this basic model of deciding what XML needs to go to the server, and sending it, you can pretty much get anything that you want. Now, there's a separate API, if you will, that we need to know how to use to actually create items in the calendar. It's called create item. Same template as find item. You create a shape that specifies what properties you're planning on specifying as part of the object. If you don't specify an object property in the shape, it doesn't get set on the object. That means that when you first start working with create item for a particular item type, there's going to be some back and forth flailing happening as you learn which specific properties Exchange requires, because not all of them are clearly called out in the 2007 book. This is one area where watching what happens when you create a mail message or you create a calendar item or a contact on an existing device is really valuable, because you can see exactly what properties they're posting. So if we look at what this looks like when we add an item here, actually, you know what, I think I have this in a slightly more readable form. Yeah, here we go. So this is a create item block. And then if you look at what's in it, this should be very easy to understand. Okay? Subject is Exchange party, there's a body. All of these parameters are things that you would commonly see in calendar invitations. Is there a reminder? Who are the required attendees? Well, in this case, it's the demo mailbox and it's me. So when we pass this up to the server, assuming that we formatted it properly, the server is going to interpret this as a request to create a calendar item on the target calendar. Well, creating a calendar item that has an attendee specified is also going to generate an invitation. So check that out. We didn't have to generate an invitation message and send it. We just add the item to this user's calendar, and the Exchange business logic that handles the calendar will take care of sending the actual message for us, which is actually kind of handy. Okay, briefly, before we get to the Q&A period, I want to talk about a few things that you can do in Exchange 2013 with EWS that you may not have realized are accessible in EWS. The first is that we have something now called the Unified Contact Store, or UCS. The reason for this is because of Link. Do I have any Link admins in here? Anybody from the Link product group? Okay, I can talk bad about them. For a long while, Link kept all of its contact data for individual users in a SQL database. Okay, the problem with that is that nobody in the known universe and nobody in the history of Exchange has ever kept their contact data in SQL. So you had this weird situation where when you provision a new user in Link, you have to go through and add all their contacts because there's no equivalent of a gal. There's an address book, but it's not the same as a gal on Exchange. It doesn't work the same way. So it was a real hassle when you created new Link users to get their contacts set up the way that you wanted them. So one of the ways that Microsoft chose to address that is by using this Unified Contact Store. which gives Link a way to use the Exchange storage mechanism as a place to keep contacts. So there's a component of Link called list for the Link storage system that's an abstraction layer. Link makes a request that says, please store a contact for this user. And depending on how you have Link configured and which version of Exchange you have, List will decide whether to put it into a SQL database like it used to or into the UCS. So when you enable UCS, there's a back and forth negotiation that has to happen between the Link client and the Link server. But once that negotiation is complete, when a user adds a contact, it shows up in a new folder called Link Contacts underneath the user's default contacts folder. If you've seen suggested contacts in Exchange 2010 and later, same basic idea. You just suddenly get a new contacts folder that has stuff in it. So there are specific EWS commands, if you will, that you can use to modify the items in that folder. You can, for example, say, okay, I want to get the IM contact information for a contact out of the folder. I don't want their phone number. I just want to know what their SIP URI is. Or I want to create a new group of IM contacts and put a bunch of people in it. It's probably more interesting to talk about what you can do with high-resolution photos. Okay? In Exchange 2010, we had GAL photos, but they were limited to 96 by 96 resolution. Now you can have photos of up to 648 by 648 with the caveat that not every client will show every resolution. So even Outlook 2013 will not show you the full 648 by 648 picture. But Link will, so when you get an incoming call, instead of getting this little tiny image that's blown up so that it looks terrible, you get a nice looking or decent looking higher resolution photo. Exchange stores all of these. That's part of what's so cool. Exchange will store the photo at whatever resolution you put in. It will downsample it to each of the supported resolutions. There are 9. From 648 by 648 down to 64 by 64. Then it will take a downsampled copy and put it into the thumbnail photo attribute in AD so that even older versions of Outlook can still see it. And then it gives you 2 ways to get to it. One is that you can just access this URL, which is kind of neat because this doesn't require you to write any EWS or anything. You just do an HTTPS GET against this URL and you get the picture. You also can use the Get User Photo EWS block to get it. So depending on what you want to do, this is a scheme SharePoint uses, for example. So to embed your user photo in a SharePoint My Page, SharePoint just asks this URL, hey, give me the picture, and it takes what it gets back and displays it. E-discovery and retention. I have to be honest, it's not clear to me who's going to want to write apps that use these APIs except for people who are making e-discovery and retention solutions. But the point is that you could, right? This is a great example of a feature that shipped in Exchange 2010. It shipped with great improvements in 2013, and it's accessible in EWS. So Microsoft is making what looks to me like a concerted effort to expose as many different item types and data types and capabilities through EWS as they can. I think that speaks well for the future because there may come a time when everything that we need to do, even in a really rich, full-featured client like Outlook, can be done without using MAPI. And personally, I think that would be okay. Okay, a few resources. There's a good MSDN article that covers all the changes and improvements in Exchange Web Services for Exchange 2013. I think all these other track resources, except following me on Twitter, you've probably already seen, so I'm not going to belabor them. This should look very familiar to you. Please fill out your evaluations. Not only do you win swag, but then we get some sense of how the sessions went and who gets to come back next year and who gets dropped into pots of boiling oil or pummeled with Microsoft Kin devices. You know they still have some of those left, right? They were actually, there was a bug bash in Redmond not long ago, and that was one of the prizes. You got a Kin. It's still in its little original container and everything. So they've gone from being perceived as a failure to being perceived as like I don't know, a nifty prize or something. Okay, we still have some time for questions, assuming you have any. So fire away. Yeah.
When you're getting calendar items, as far as the HTTP post authentication for delegate objects, you get
So that's a good question. His question was, when you're getting calendar items, if you have delegation in place, what are you going to get back in the auto discover manifest? Whoever you authenticate as, you're going to get back the manifest data for that user. So if you're Bob and you are a delegate of Alice, if you authenticate as Alice, you're going to get a URL to her mailbox server from which you can get her calendar items. If you authenticate as Bob, you're going to get back Bob's mailbox server. Now, having said that, if you're logged in as Bob to your mailbox server, you can request items that belong to Alice with find item. But you have to have a way in your app to look at the delegate permissions themselves. And those are exposed in EWS also, but you have to ask for them. They're not included as part of Auto Discover or as part of any of the other data that you're normally going to get back. Yes, sir.
Have you tried to be able to pull in data with the Outlook's like sticky notes? The notes that you can put in Outlook? I've done it in PowerShell, but I can't seem to be able to do it within Xcode.
You know, I haven't tried, actually. I didn't know anybody was still using Outlook Notes. It's a really good question. As far as I know, the note data type is exposed. It was exposed in Exchange 2007 EWS, and I don't think they deprecated it. But
I haven't been able to really find anything to show me kind of how to pull that data.
if you don't mind, send me an email and ask me that same question, and I'll do some digging and see if I can find the answer, because now I'm kind of curious about that.
And do you have any of your sample code available?
I will. I do intend to post it.
Okay.
I would like to take out a few of the to-dos first and a few of the more egregious uglinesses so that real iOS programmers don't laugh at me when they see it. But okay, any other questions? Yeah, in the back.
Do you have any good troubleshooting techniques or something when we determine if we're missing like a specific tag or anything like that?
That's great question. Do I have any specific troubleshooting tips or techniques to figure out when you're missing a tag or when you've malformed XML in some way? When I was developing these and when I was writing about these APIs, what I would always do is run the operation with a device that I knew would work. So I'd use a Windows Phone device or an iOS device or Windows Mail or something else that I knew used EWS and did what I wanted to do. And then I would look at the returned output that I saw from Fiddler and use that as a model for what I emitted in the first place. Because before I started doing that, for example, it took me a day to figure out, I mentioned earlier that you have to have content type text whack XML. It took me a day to figure out that that's why Exchange was rejecting my XML blocks. I mean, it's just incredibly frustrating. So there are probably people who are more experienced in working with XML services who have better, more useful tips. But my best tip I can give you is look at an application that works properly and compare the output from it to the things that you're providing. And generally, it'll be pretty obvious what you're missing if you do it that way. Plus, the other thing that's nice is after you've done this a couple of times, you'll start to build up a library of working XML that you can customize when you want to call find item or create item or any of the other routines. You've already got data that tells you, you already have the results of previous runs that tell you what needs to be in the XML block, and there it's just a matter of adjusting what you put in the shape for the kind of item that you're trying to work with. Yes, sir. Mm-hmm. Okay, that's a good question. So his question is, if you have a line of business app that you write using EWS and you have an employee who leaves or they lose a device or something and you want to remotely erase it, how do you do that? So I guess the simple answer would be that you can use Exchange ActiveSync to send a wipe request to the device if you have an Exchange ActiveSync partnership. Where you run into trouble, let's say that you have a device that does not have an Exchange account on it, it's not synchronized with Exchange, it just has your app, right? In that case, there's no way for you to tell it to remotely erase itself unless you build that into your app. And then for that to work, whoever stole the device has to launch your app so that you can send the wipe command to it on connection. So what I think I might do in a case like that, if you were worried about users caching sensitive data in your line of business app, is I would do something like check and see if there's an Exchange account on the device at launch. If there is no Exchange account, then wipe out whatever cache data you already have. Right? Yeah, but that's true. It is. But somebody who can launch the app, assuming you don't have separate, a separate PIN or password or something, somebody who can launch the app can still look at the data on the device itself. But you're right, because it's sandboxed, you don't have to worry about another malicious app on the same device stealing it. Right? Is that what you're getting at, or? I mean, yeah, because it's still there. And depending on how you store it, if you store it with SQLite or you store it as raw XML, some other technology like that, then a smart attacker can essentially forensically get that data off the device and examine it. Will they bother? No, probably not. Right? One of the things that mobile device management as a whole is still missing is a way for me to say, okay, I want to remotely erase this device, but I really only care about the data that belong to applications A and B. I don't want to wipe out all the users' photos or their collection of cat videos. I just want to get my sensitive corporate data off the device. But there again, we've only had smartphones for, 15 years now, so maybe in another 15 years we'll have that problem solved. Okay, any other questions? All right, thanks for coming. Enjoy the rest of the show. Fill out your evaluations. Look both ways when you cross the street. Eat your vegetables. Y'all know the drill.